So here's the kit that we're going to be putting together. It's the NE555, and this is a signal generator. And it is a relatively simple one. We'll take a look at a couple places where you can buy this kit in a few minutes. But this kit, I think you can get it for like $2 or $3. Depending upon where you get it, you might pay a little bit more. You might have to pay for shipping. But taking a look at this, there's not much here in terms of instructions. There's a lot of foreign language on here. But what it does do, like if you look here, it's 10K ohm resistors. There should be 3 of them. And it would go to R5, R6, and R7 on the board. And then here is a bit of a schematic if you want to understand how this thing works and maybe take a look at it. What I like to do is I like to refer to these schematics maybe as I'm building, but also at the end of the project. Then it helps give me a little bit of an understanding as to what I did and why I did it. Let's go ahead. We got parts already coming out of everywhere, and I don't see so well, so I want to keep all my parts in a bright bin like this that's extra visible, so that way I can make sure that everything is where it's supposed to be. I can find it and put it in there. So here's the board, and then I'll roll in a close-up of this, but each one of the parts where the resistors and capacitors and all the pieces go is labeled pretty well. So I really don't think I need instructions for this. It should be a relatively easy assembly. Now there's some writing here, and it looks like it's in Chinese. I'm not exactly sure what that says, but I'm pretty sure it says subscribe to the Smoke and Ape channel. All right, well, let's get this thing in a vise, and we'll get started on the build. Okay, so as I'm getting ready to get started and I'm getting organized here, one of the things I like to do is I like to take a look at these. So because they're bundled together, I know that all 3 of these are the same value. Now you can look at resistors, and based off of the color bands here, you can determine their value. I don't do that. I use a multimeter because I'm not trusting myself to do that correctly. It's not going to happen. When I take a look at the instructions again, you can see that I have 1 kilo ohm 3 and then 10 kilo ohms 3. So that tells me that these are either 1 or 10 kilo ohms. So what I want to do is I want to measure these, and then I'm going to go ahead and I'm going to put them on the board. And that helps me get rid of stuff in this parts bin, and it makes it easier to find out where the other stuff goes via process of elimination. I always start with resistors and lower mounted things on the PCB first because it makes it a little bit easier. So here we have our multimeter, and it is set to measure resistance. And so what I'm going to do is I'm just going to go ahead in here, and then I'm just going to clip these bad boys in to see what we get. Using clips like this makes it a little bit easier than using probes in a situation. So hopefully you can see that's a kilo ohm setting, 0.9. So this would be our 1,000 kilo ohm resistor. So let's not mix those up. And then let's go ahead and measure these, and these should be 10K. And 9.92, and that's likely within spec. I don't think that these are high quality components. 10K, 1K. So what we want to do now is we want to get this out of the way. 10K, 1K. Let's not mess that up. So let's take our 10K, and then according to the instructions, R5, R6, and R7. So when we take a look at our board in here, hopefully this will come through, but right here is R5, R6, and R7. Let me check that myself, make sure I'm right. Yep, it's these first 3 resistors right here. So what I want to do is I want to take the paper off of these resistors. And what I do is I just take a little and bend them a little bit like this. And then I just go ahead and I put them in. Now some folks get all uptight about how you put these in your board, and they say they all have to be orientated the same direction. I don't worry about that so much because my eyes are so bad I can't tell anyway. But that's one that's in there. Let's go ahead and get the second one in there. Some kits will send you your components already bent for installation, which is nice but not necessary. And instead of sitting here jibber jabbering your ears off, I'm just going to go ahead and put these in. We're going to speed it up. Okay, one thing I did notice that there is one diode D1 in this kit. Diodes are directional, so you can see here on the board it has that white bar, and so your diode has that as well. Now I'm just going to go ahead and put this one on here because I see that it goes right there, and I'm going to solder all these resistors that we put in place. But by putting this diode in there, again, this becomes another process of elimination time saver. That goes on here, and I don't have to continue to search or fiddle through parts. And there we go. Now, one of the things I do is I do bend these legs over a little bit when we put them in like that. Makes it just a little bit easier to hold them in place and to solder. So we're going to solder. This thing always gets me. We're going to go ahead and we're going to solder these, and then we're going to come back and put the rest, continue putting the rest of the components in place. Okay, so we have some of the resistors and the diode on there. So one of the things I like to do is that as I go through the list of parts, I just mark off all the ones that have been installed, and then that will make my job easier as we go along. All right, let's figure out what is next. Okay, what I did is continue to work through the piece of paper on all the resistors. I used the multimeter. You can see we have none left in the bucket, and they're all here on the board. And so now we need to go ahead and solder those on. All right, taking a look at this, the next thing I want to do is I want to put on the IC. And so you can see this is where the IC goes. And there's a key in there, or a little indentation. And this is a socket for that IC, and you can see that same key there. So when we put this in, we want it to... Oh boy, let's see if that thing's going to go in there or not. Doesn't look like it's going to be easy. All right, some of these legs on here are a little bent up, so we're going to have to straighten those out. There we go. And that's where the socket goes, and then your IC, in this case the 555, is right here, and you can see that has that same little notch or key on it, and we'll put that in after we're done everything else. But first we want to put this key in here. Now, in order to hold this key in place, sometimes I use blue tape, but today we're not going to use blue tape. We're going to use blue tack. Fun Tack mounting putty from Loctite. I'll put a link to this below. This is 2 ounces, and it lasts forever. And what will typically happen is that you will lose your blue tack before you use it up. So let me go ahead and get a piece of this real quick. And then what you want to do is you want to make sure that this is mounted correctly and flush. Hold that in place and put some of this sticky blue tack in there. And that'll help you hold it. Now, that one piece is probably enough, but I'm just going to put a little piece over here as well. And then you can see when I flip this upside down, the IC circuit mount, or whatever you want to call that thing, socket, is in place. And then so what we want to do is we're just going to run down here and solder these real quick. So I got it in there. One of the things I was worried about is a couple of these are a little close together, and I wanted to make sure they weren't touching, and it doesn't look like they are. But I just wanted to make sure. All right, the next thing we're going to take a look at are these little ceramic capacitors. And these things are super small. And let me go ahead and put one here. And then hopefully you'll be able to see that each one of these has a number on it. And I will get a camera shot and zoom in on that. And those numbers correspond with a value on our instruction set. So for example, over here, we have a ceramic capacitor 103, and it would go into C9 on the board. That's easy enough. And each one of these has a different value. The problem is that they're small. And the other thing is that when you stick these legs through, instead of bending them as wide as we did for the resistors, we just bend them a little bit because we don't want to break any of the plates inside of these ceramic capacitors. So let me go ahead and get these on the board and we'll come back. So far, this has been a nice, easy kit, which is enjoyable for a change. One of the things I wanted to say is I put all the capacitors in. They're all in place. So one of the things here is you'll see you have a 103 and we have a 103. And some of these are different. See how this one is different from that one? So there are a couple that are a little wider, and they go in wider spots in the board. Maybe that distinction is made right here, but I don't know what that says. So you just kind of have to guess. 103 is a standard value, so you should be fine either way. But just look for where they fit on the board if you decide to build this kit, which has been, it's been a nice little kit build. I like kit builds. So let me go ahead and I'm going to get these soldered in, and then we'll keep moving. All right, so these are all in, the capacitors. Now, these are electrolytic capacitors, not ceramic capacitors. These are 4.7 microfarads. And these are a little bit different because they have polarity to them. You can see one leg is longer. That's supposed to be the positive leg, and they have a white bar. Here on the board, you'll see a white bar, and then you'll see a positive sign. So we're going to put those in the two spots for the capacitors. I wanted to mention that ceramic capacitors are non-polarized or don't have polarity. These capacitors do. So you want to make sure that you're careful, and I almost just put this one in backwards. But they're easy. They go in, and once they're in, we do the same thing where we slightly bend the legs out. Somebody will come on here and be like, "Ape, that ain't a slight bend." But we just bend the legs out, and then we're going to put this other one in, and then we're going to keep on trucking. Uh-oh, might have to get, there we go. Thought I might have to get the magnifying glass out to do that. All right, let me solder these real quick. All right, so next on the list is that we have two of these little transistors. They go on the board here and here, and that should be easy enough. Now, what you want to make sure is, because these have three legs, that you separate them a little bit and then you get them in the right place. And this is going to be a pain in the butt, I can tell. I can tell you that right now. I'm never going to be able to do this one-handed. Well, how about that? It went in. Now, when you push these in, these don't go all the way flush mount. If you want to do that, you're going to have a little bit of trouble. So I got the transistor in there, and then we're going to do the other one. And we're going to do it off camera because it was such a debacle. Okay, we have not seated our IC yet. And then we have this little device, and we have this little device, and we use that on jumpers. So let's talk a little bit about jumpers. We have this here. Oh, by the way, when I was putting on these transistors, I just added the potentiometer. Sorry you missed that. Well, I'm not that sorry. But anyhow, what I'm going to do is I'm going to break these up into sets of two. You can see that a jumper set goes here, 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 and here. And then you would use this to change your waveform. So you can see we have square, sawtooth, triangle and sinusoidal. And it looks like underneath this piece up top here, it's going to be a little tricky. Let's just pull it out. Right here we have a spot where we also, maybe we'll just go ahead and do this, where we're also going to have to apply some of these jumpers. So let me go ahead and get that all taken care of, and then we'll come back and see where we're at. So just so everybody can see what's going on here, I put these jumpers in. Here we go. I put these jumpers in, and I use a little bit of blue tack to hold them in place. And I'm just going to go ahead and I'm going to solder these in, and then I have 3 more sets right here to go. We'll come back when that's all done. All right, folks, so the board is done. All the components, actually it is not. Let's go ahead and, remember I talked about this having a key in it as well. So we want to make sure that our IC goes in correctly. And this is a relatively easy thing to do. Maybe it's not. Yes, it is. There it goes. Just seated in there just fine. All right, so like I was saying, the board, let's just start over. All right, and so our board is done. We've seated the IC, making sure to pay attention to the key mark. All of our jumpers are on here. Now this one is our input voltage and ground, and so there's no jumper to be added there. And then I'm assuming this one is where the signal comes out. There's a lack of instructions here. And then, as I mentioned, depending upon the type of signal that we want or waveform, we can go ahead and we can put this jumper on those sets of pins, just like that. Relatively simple. And then right here is our potentiometer, and I'm assuming this is to adjust frequency, and maybe it's to adjust amplitude. I don't know. We'll have to set it up and test it. So the next thing for us is to go ahead and test this board, which we're not going to do right now because I'm tired. So I'll see you in a little bit when we test it. Okay, so here's the finished product. A couple of different things I wanted to mention. I did put some standoffs on here. I like to do that because when I mess around with these little boards, I don't want to have any metal or anything hit the back of this and cause a short or cause a problem or damage any of the delicate soldering that I've done. So that helps it stand up. The problem is it only has 3 holes. It doesn't have one over here, so it's a little unstable, but that's okay. We can live with that. The other thing that I wanted to mention is that I put some of these DuPont pins, female on this side to male, so they went into the jumpers here. And this one is our power source. This thing says it can run anywhere from 5 to 12 volts. Today we are going to juice it up with this BioNO 12 volt lithium iron phosphate battery. Heck of a battery, guys. And then on this side, this is our wave output. So this would be the ground and this would be the signal. I believe is what they're calling it. They call it the out. And the other thing is that here we have a potentiometer that does adjust amplitude. I was able to discover that. And then we can move this jumper here across these different pins and get different waveforms. Right now it is set on square wave. And let me go ahead and move this over to the sine wave. And I got to tell you, you got to have good hands to do this. It's a little tight fitting in here. And there we go, it's on. All right, let's take a look at connecting this up, and then what we'll do is we'll take a look at see how the signals look on the scope. Because this is our signals out, we're going to turn it this way. And what I'm going to do here is I'm just hooking the ground of my scope probe up, and then I'm going to connect the main part of the probe up to that. And now what we need to do is we need to connect these to our power source. So let me do that real quick off camera, because I have had let the smoke out before doing that, and I don't want to do it again. Okay, because safety is always our top priority. So here are the leads coming from the battery. Let me just go ahead and plug those in right now. We have them isolated here with our isolation device to make sure that these 2 alligator clips don't touch, because when that touches, it is definitely not fun. So let's go over and take a look and see what we got going on this scope. So here's me and here's the scope, and then you can see already that we have a little bit of a sine wave there. Let me just go ahead and hit the auto button so it goes ahead and pulls it in for us. This is not the cleanest of signals. It's not bad, but it's definitely not the cleanest. There we go. Oh, it doesn't look like it's going to cooperate with us so much. So let's just go ahead and hit the stop. So you can see that there's some artifacts when they're on the sine wave. Not so much a big deal, but it's there. And again, this board is only a couple of dollars. So when you do a kit build like this, there's not a whole lot that you should expect. Now I'm going to adjust the potentiometer that we talked about before. Right now I have it set all the way at peak. And you can see that as I adjust it down, our sine wave changes. And let me go ahead and take this call, and I'll be right back. And we're back. We ended up not taking the call. So what I'm going to do here is I'm just going to go ahead and fiddle-faddle a little bit. And let's go ahead and try, I believe this is the sawtooth wave. There we go. And it is on there, and we can adjust a little bit to get a look at it. And then you can see every so now and then artifacts are popping through. Now, I don't know if this is a mistake that I made during the construction of this board or not, but if I take the jumper completely off, you can see here that we do have something making its way through the board. I don't know if that's the quality of the components. I don't know if the chip's bad. I could replace it. I have some spares, but I don't think I care enough. It's just something that's there. Let's take a look and see what the square wave looks like. What's going on here? Did I put that on there right? There we go. And then you can see the square wave. Now I might need to compensate the probe a little bit here and see what's going on. But anyhow, I just wanted to show you it is assembled. It is working. We're going to call it a success, although the quality of components is not exactly where I want it to be. But at the end of the day, I think I had some fun putting this together, learned a little bit, and I think I can play around with it on the scope for a little bit and maybe learn a little bit more. So I'm going to leave it to that. Thanks for watching, everybody. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below, and I'll do my best to respond. Thanks for watching.